Okay, so in this video we'll see how to finish our quantum teleportation protocol. So remember where we were? We had Alice had this qubit alpha 0 plus beta 1, and we imagined that we had a C0 gate. So we got Alice and Bob to share the state alpha 0 0 plus beta 1 1. And then we said, if Alice wants to now do something at her end so that Bob is left holding the qubit she started with, alpha 0 plus beta 1, then she can do this by measuring in the sign bases. What happens is, if she measures a plus, then their joint state is plus tensor alpha 0 plus beta 1. And if she measures minus, they have minus tensor alpha 0 minus beta 1. What Alice does is calls Bob and tells him what her measurement outcome is. And if she says plus, Bob leaves his qubit alone. If she says minus, Bob performs a phase flip, Z. Okay, so our challenge now is to try to achieve try to create the state alpha 0 0 plus beta 1, but without a C0 gate. Okay, so now what helps us is the fact that Alice and Bob actually share a Bell state. So we'll think of these as three different wires. The first wire carries Alice's qubit, alpha 0 plus beta 1, and the second and third wires carry these two qubits, which are in a Bell state. They are entangled in a Bell state. So how should Alice try to create the state alpha 0 0 plus beta 1 1 shared with Bob? Well, since she can't apply a C0 from her lab directly to Bob's lab, maybe it's a good idea for her to apply a C0 from her qubit to her share of the Bell state. Okay, so now let's figure out what the state of these three qubits is after she applies the C0 gate. Well, so first, let's figure out what's the state before she applied the C0 gate. Well, it was alpha 0 plus beta 1 for her qubit times 1 over square root 2 0 0 plus 1 over square root 2 1 1, which is what? Alpha over square root 2 0 0 0 plus alpha over square root 2 0 1 1 plus beta over square root 2 1 0 0 plus beta over square root 2 1 1 1. Now what happens when you apply a C0 from the first qubit to the second qubit? Well, nothing changes on these two because the control bit is 0. But here, in these two cases, the control bit is 1. And so you get alpha over square root 2, 0, 0, 0, plus, so that's this term. If you look at this one, this control bit is 1, this target bit is 1, so it'll become 1, 0, 1. So you'll get beta over square root 2, 1, 0, 1, plus alpha over square root 2, 0, 1, 1. And then you have this, so we took care of these three. Out here we have control bit 1, target bit 0. So we get beta over square root 2, control bit 1, target bit 0, so we'll get 1, 1, 0. So now, what do we plan to do? Well, we plan to now, what happens if Alice now measures the second qubit, the middle qubit? Well, if she measures the middle qubit, either she gets as outcome 0, which happens in this case. And if she sees the outcome 0, what's the state of the first and the third qubit? Well, it's what she gets is alpha 0, 0 plus beta 1, 1. So if the outcome is 0, then the new state on the first and the third qubit is alpha 0, 0 plus beta 1, 1. What if she measures that the output of the middle qubit is in the state 1? Then what's the state of the first and the third qubit? Well, now it's alpha 0, 1 plus beta 1, 0. So now what Alice must do is pick up the phone and call up Bob and tell him whether she got a 0 or 1. If she got a 0, then Bob leaves his qubit alone. And Alice and Bob now share the state alpha 0, 0 plus beta 1, 1. In the last video we saw how from this Alice can do a measurement, and then Bob ends up with the unknown quantum state alpha 0 plus beta 1. That's the end of the teleportation protocol. On the other hand, if she calls him up and tells him, I got a 1, then what Bob does is he applies a bit flip to his bit. So what happens? Well, when he applies the bit flip, what he ends up with is alpha 0, 0, because this 1 gets transformed to 0, plus beta 1, 1, which is exactly the state, again, that we wanted, and then we carry on with the protocol from last time. Okay. So now we can put everything together. So here's the teleportation protocol. So remember, everything above this midline, something like this, is Alice's lab. Everything below is Bob's lab. So now how do they proceed? Well, Alice has her qubit. This is the one she's trying to teleport. And then Alice and Bob share a Bell state. That's Alice's part of it. That's Bob's part of it. So what's the first thing Alice does? Well, Alice performs a C0 from her qubit, the unknown qubit, to her share of the Bell state. She measures that, the middle qubit. Okay? And she calls up and tells Bob the result of that measurement. If it's a 1, then Bob must perform a bit flip on his bit. That we can represent, if we want, as this controlled X operation, where if this bit is a 1, then Bob performs a bit flip, and otherwise he leaves it alone. Of course, there's no control wire here. This is Alice calling up Bob and telling him 0 or 1, apply the bit flip or don't apply the bit flip. Then what happens? Well, then the other thing Alice does is she wants to measure her qubit, the first qubit, in the Hadamard basis, right, in the plus-minus basis. So to do this, another way she can do this is she applies the Hadamard transform to her qubit, and then she measures in the standard basis. Right? Make sure you understand that this is the same thing. So instead of measuring in the plus-minus basis, is the same thing as first applying a Hadamard transform and then measuring in the standard basis. And then again she calls up Bob and tells him the result of that measurement, and if it's a 1, Bob applies a phase flip to his qubit. Now, from what we have seen before, the result of this is that Bob's qubit is magically now in the state psi, which was the state of Alice's qubit. Again, why does this work? Well, this C0 followed by the measurement and results in the first and the third qubit either being in the state alpha 0, 0 plus beta 1, 1 or alpha 0, 1 plus beta 1, 0. In the second case, Alice calls up Bob, tells him apply a bit flip, and they end up in the state alpha 0, 0 plus beta 1, 1. Now what does Alice do? Well, Alice measures her qubit in the Hadamard basis. She calls up Bob, tells him what the result of her measurement is, 0 or 1. If it's a 1, Bob applies the phase flip and he reconstructs the unknown qubit. Now, this unknown qubit was specified by two complex numbers, alpha and beta. Alice everything up here is happening in Alice's lab. Alice called up Bob at this point and she told him two classical bits, B1 and B2. So a question, where did these complex numbers actually get communicated to Bob? It's a mystery. This is the power of entanglement. So this entanglement creates a channel through which alpha and beta implicitly made their way to Bob. It's a very interesting mystery to ponder over.